Welcome to Two Projects. In this video, we are going to explain the project Political Security Threat Prediction Framework using hybrid lexicon-based approach and machine learning techniques. Introduction. This project addresses the critical intersection of national security and cyberspace, focusing on the evolving landscape of cyber-related threats highlighted in the worldwide threat assessment of the US intelligence community. The primary goal is to develop a political security threat prediction framework utilizing a hybrid lexicon-based approach to analyze sentiments and emotions embedded in online news. The aim is to predict and manage potential threats to political security, a key element of national security. With cyberspace becoming a breeding ground for big data, misinformation, and emotions, the project recognizes the need for real-time detection of disruptive sentiments. Understanding the relationship between emotions in online content and national security threats is crucial for early threat management. Existing opinion mining methods and related research have not fully explored the connection between emotions and national security threats. The project identifies this research gap and emphasizes the importance of comprehensive exploration in the realm of political security. So the project's outcomes are expected to benefit authorities involved in national security by providing a predictive framework for political threats. The proposed hybrid approach combines the lexicon-based method and machine learning techniques including decision tree, naive-Bayes, and support vector machine, with experiments conducted using online news data to validate the framework's effectiveness. Objective of the project. So, as I mentioned earlier, the primary objective of the project is to develop a hybrid lexicon and machine learning based system to analyze public opinions and news sentiments, predicting potential threats and facilitating preventive actions for political stability. And we aim to utilize social media reviews to actively monitor sentiments, aiming to prevent civil unrest, riots, or terrorism by promptly addressing negative public opinions through government intervention. And we aim to introduce a novel approach combining lexicon, NRC, that is calculating emotions, and machine learning algorithms. Lexicon NRC identifies emotions, categorizing them into positive or negative, which along with news text trains a machine learning model for threat detection. And we aim to employ support vector machine, naive-Bayes, and decision tree machine learning algorithms, assessing their performance in terms of accuracy, precision, recall, and F-score. And requirements needed to execute this project are software requirements. Software needed is Anaconda, primary language used is Python, front-end framework used is Flask, back-end framework used is Jupyter Notebook, database used is SQLite 3, and front-end technologies used are HTML, CSS, JavaScript, and Bootstrap 4. Hardware requirements needed are operating system of Windows, processor of i5 and above, RAM of 8GB and above, and hard disk of 25GB and above. Now we'll discuss the working modules of flow of work. So the first step is importing required packages. So in this initial step, essential Python packages are imported to facilitate data manipulation like pandas, for machine learning like sklearn, and for natural language processing like NLTK. These tools lay the foundation for subsequent analysis. The second step is exploring the dataset. So this stage involves a thorough examination of the dataset, focusing on online news articles. The goal is to gain insights into the data structure, content, and overall characteristics, providing a foundation for subsequent processing. The third step is data processing. So here, data undergoes a comprehensive pre-processing journey encompassing the removal of stop words and special symbols, lemmatization, NRC lexicon analysis for emotional features, and TF-IDF transformation. These steps refine the dataset for effective machine learning model training. The next step is splitting the data to train and test. So in this step, the dataset is divided into training and testing sets, a crucial step in evaluating the machine learning model's performance. This separation ensures unbiased assessments on unseen data. The next step is training and building the model. Here, machine learning models including SVM, naive-Bayes, and decision tree are trained using the pre-processed data. And in the next step, beyond standard models, the project extends to construct a random forest model and a hybrid model. This innovative approach combines predictions from multiple models, enhancing accuracy and robustness. And the project integrates Flask, a web framework, to develop a user-friendly interface. And Flask is also coupled with SQLite to implement secure user authentication, ensuring controlled access. Flask with SQLite facilitates user registration and authentication. This contributes to a secure and user-friendly experience within the application. And after signing in, users input data through the frontend, and the provided information undergoes pre-processing, mirroring the initial data processing steps. This ensures consistency in handling user-generated content. And the pre-processed user input is fed into the trained machine learning models. And this step aims to generate predictions based on the trained models. And the final predictions are presented to the user through the front-end interface. Users receive real-time insights into whether the input suggests a potential threat or not. Now we'll understand about the algorithms used. So the first algorithm built is support vector machine, that is SVM. So SVM is a classification algorithm that works by finding the optimal hyperplane that best separates different classes in the feature space. In the context of this project, SVM is used to classify news articles into either a threat or no threat category based on the features extracted from the text. SVM aims to maximize the margin between classes, making it effective in handling complex decision boundaries. The second algorithm built is naive Bayes. So naive Bayes is a probabilistic algorithm based on Bayes' theorem. It treats each feature independently, assuming that the presence of a particular feature is unrelated to the presence of other features. In this project, naive Bayes is employed to calculate the probability of a news article belonging to the threat or no threat category, giving its features. Despite its simplistic assumptions, naive Bayes often performs well and is computationally efficient. The next algorithm built is decision tree. So decision tree is a tree-like model where each internal node represents a decision based on a specific feature and each leaf node represents the final outcome or class. Decision trees are interpretable and can handle non-linear relationships, and in this project, decision tree is used to classify news articles by recursively splitting the dataset based on the most informative features. And the simplicity and transparency of decision trees make them valuable in understanding the factors influencing predictions. Now we'll see the comparison graphs. So this is the horizontal bar graph comparing accuracies of different algorithms. So in this graph on x-axis I have accuracy scores and on y-axis I have algorithm names. So accuracy measures the overall correctness of predictions, showing the percentage of correctly classified instances. And this is precision scores comparison graph. In this graph on x-axis I have precision scores and on y-axis I have algorithm names. Precision measures the accuracy of positive predictions, indicating how many predicted positives were actually correct. This is recall scores comparison graph. In this graph on x-axis I have recall scores and on y-axis I have algorithm names. Recall measures the ability to identify all relevant instances, showing how many actual positives were correctly predicted. And this is F scores comparison graph. In this graph on x-axis I have F1 scores and on y-axis I have algorithm names. F1 score combines precision and recall into a single metric, balancing accuracy and completeness in predictions. So the algorithm which is best performing in all the performance metrics will be used for predictions. Execution of the project. To execute this project, first we need to open the code folder which contains the project source code files. So this is the dataset folder in which I have online news dataset with class labels on which we will train the models, and this is test data which does not have the class label on which we will evaluate the models. And this is model folder which contains NumPy files. These files contain algorithm information. These files will be loaded into the project code during runtime to utilize the trained models. And this is static folder. This folder consists of files related to CSS, JavaScript and Bootstrap. This is templates folder. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. This is app.py file. This .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in the HTML pages. And this is Jupyter source file. So this Jupyter source file contains a combination of code, graphs and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for data science. And this is signup.db file. This file is the database file used to store user information. So now copy the path of the code folder from the address bar of the file explorer. I'm copying it. Open Anukunda prompt. So use the command cd followed by a space and paste the copied path and hit the enter button. So this command is used to change the current directory to the code folder's path. So now compile the app.py file using the command python space app.py. I'm typing python space app.py and hit the enter button. So this command will execute the Python script and perform a runtime check for any syntax errors or logical issues. After running the app.py file, the Flask framework will host the application locally at the default address localhost and port unless configured differently. Now copy the local link provided by the framework. I'm copying it. Paste it into any web browser. I prefer Chrome. After pasting it, hit the enter button. So the home page of the project has been displayed in the browser. This is the front end built using Flask framework. So here we can see a sign up link, click on it. So if we are new users, we have to register first. Fill in all these details and click on sign up button to register. And if we already have an account, we can directly log in by clicking on this link. So as I already have an account, I'm clicking on this link. So here we have to provide our credentials, username and password. And click on login button. So it has redirected us to the prediction page. So here we can see a enter your message box where we have to enter a tweet and the application will classify it as either thread or non-thread. So I have entered this tweet. Now click on predict button. So this is the given text, and for this text it has predicted it as the tweet type is thread. So the application has classified this text as thread. Now click on home link. We'll try again giving another tweet. So I have entered another tweet. Now click on predict button. So this is the entered tweet, and here we can see the label, that is the tweet type is no thread. So the application has classified the given tweet as no thread. So similarly we can enter any tweet and can get the classifications. So here we can see a sign out link, click on it. So the conclusion here is the project introduces a pioneering hybrid methodology combining lexicon-based sentiment analysis with machine learning algorithms. This novel approach enhances the accuracy and robustness of political security threat prediction. By incorporating NRC lexicon to gauge emotions in news articles, the framework captures subtle nuances in public sentiments. This emotion-driven approach provides a more nuanced understanding of potential threats. Rigorous evaluation of SVM, naive-based and decision-tree algorithms demonstrates the effectiveness of the proposed framework. And the project's focus on monitoring social media sentiments for political security has practical applications. Timely detection of negative sentiments allows authorities to proactively address emerging threats, preventing potential civil unrest or conflicts. And the project recommends expanding the lexicon and exploring advanced techniques for continuous improvement. An extension includes a random forest and a hybrid model for robust predictions, enhancing overall prediction capabilities. And the Flask-based frontend enables user testing and authentication.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.